Okay, good morning, everybody. I hope you guys are all doing okay. We actually have had some nice weather here the last few days, so that's been awful nice to be able to get outside maybe a little bit and stretch your legs. So I know my boys have been pretty cooped up in the house, so it's been good to be able to get them outside and burn some energy off. So hope everybody's doing good. So today I'm going to talk about the natural logarithmic function. Now, the thing to people always get confused about what the natural logarithmic function is. If you have log of x, I'm sorry, I wrote that wrong. Let me back up. If you have log of 3, if there is nothing written here, then it is automatically understood to be base 10. All right. Now, if you have log base e of 3, that's just the number e that we talked about. I had that green poster in my room. It was 2.871, something like that. They actually have another notation for log base e. For whatever reason, they decided to use ln. I'm sure it's natural log in reverse. But they use the letters ln to indicate natural log. Now, there is a natural log key on your calculator. If you look on the left-hand side, right below the log key, there's the ln key, and that's simply natural log. And it is no different than having log base e, but rather than writing log base e, they write natural log. So please don't let natural log confuse you as to what it is, because it's pretty simple. It's just log base e. Now, graphing natural log is a little more challenging. And the reason is, if you remember back from a few days ago on my last lecture, when I showed you how to graph a log function, it's very simple. You just convert that log function into an exponential, and you make a table for the exponential function, and then you reverse the x and y's, and then you get the graph of the log. Now, it's nice when the logs have easy bases like 2, 3, or 4, or 5, or any whole number, essentially, because any of those whole numbers are very easy to take to a power. You know what 2 squared is: 2 to the third, 2 to the fourth. But when you are dealing with natural log, base e, 2.71828, something like that, is not as easy to figure out what it is when it's being squared or cubed. In fact, you really can't do it on your own without a calculator. So what I'm going to show you is how to graph the natural log function using your calculator rather than doing it by hand. And again, this is what I just showed you in the previous slide where I wrote it out. F of x is equal to log base e of x. When the base is e, they notate it as natural log. And please don't get confused right here on this natural log. It does not have a base 10. Natural log is log base e. So this natural log, when there's nothing here, it's only ever base e. That's the only thing natural log means. It can't have other bases like the regular log function can. So it says the above definition implies that the natural logarithmic function and a natural exponential function are inverse functions of each other, which goes right along with what we discussed before, that logarithmic and exponential functions are inverses. So every logarithmic equation can be written in an equivalent exponential form, and that means basically the very first log rule that we learned. And every exponential equation can be written in equivalent logarithmic form. So it says that is y equals natural log of x and x equals e to the y are equivalent equations. So again, if you take this from logarithmic form and you put it into exponential form, this is log base e of x equals y, the very first rule that we learned, base e to the y equals x. And that's what you got right there, e to the y equals x. And you can see this is the graph of e to the x, so 2.71828818, to the -2, -1, 0, to the first power, and then this graph right here is the natural log of x, which are just these ordered pairs reversed. Now, as I said, I'm not going to have you graph that using by hand because you can't take that number to a power in your head. So this just wants you to use a calculator to evaluate the function f of x equals natural log of x at each value of x. So we're going to start with x equals 2. So right here, we're going to tap the natural log, and then we're going to fill in 2, and we'll hit enter. And you can see it's 0.693147, and the decimal keeps going on. The next one is natural log of 0.3. So if we take natural log 0.3, there you go, negative 1.20397. Obviously, these are pretty simple. Natural log of negative 1. Type in negative 1. Anybody want to guess what's going to happen? And you get an error. It says non-real answers, and if you hit go to, it takes you to there and says this is bad. So if you try to hit enter, you're just getting in an error. And the reason we're getting an error comes all the way back to this page back here. If you look, we tried to take natural log of a negative number. Natural log, this is the graph of log of x, very similar to the graph of natural log of x. But if you notice, the domain of that function is 0 to infinity, meaning you cannot log numbers that are 0 or smaller. So what you put in for x cannot be 0, and it can't be negative. And that holds true for any log base, including natural log. So when we try to natural log this negative 1, it is that negative 1 is not in the domain of the function. Therefore, you will get an error. Now, this last one, 1 plus root 2, you got to be careful with this. When you hit natural log and you do 1 plus square root of 2, make sure that you close out both sets of parentheses, and you get 0.88137. I keep flipping to the Algebra 1 note. Sorry about that, guys. Okay, here are 4 properties of logarithms. Now, what I always tell my students whenever we have this in normal circumstances is, again, you were allowed to keep a note card, and you could write all these rules on your note card. And I always tell people to put their log rules on one side of the note card and then put the natural log rules on the other side of the note card. But these are very similar to the rules that you've already written down for log. And the reason is natural log is just a specific base of log. It's base E. So you can see these are the same as the last ones. Natural log of 1 is equal to 0. Natural log of E is 1. Now, the reason why natural log of E is 1 is this is actually log base E of E. And so when you're logging a number that is identical to the base of the log, it all cancels and turns into 1. Same thing here. This is natural log, which is log base E of E to the x. So the natural log of E cancels, and you're simply left with x. And this is our one-to-one property, same as the last one. If the natural log of x equals the natural log of y, and then x equals y. Now, this is an example 7. I'm not sure why it says 7, but it says graph the following, and it's natural log of 3 minus x. Now, I want to go through this and kind of explain. I would not expect you to do this by hand, other than you should be able to tell me what transformations happen there, which I'm going to draw you a little picture here. I'm going to actually draw you 2 pictures. Let me back this up once. I'm going to draw a picture right here, and I'm going to draw one right here. So remember, the graph of natural log itself, all the log functions look like this. Now, if I reorder this, and I'm going to write this as y equals natural log of negative x plus 3. Now, there's two different things happening to this. The first thing is there's a -1 on the inside, and then there's the +3. So the -1 on the inside is a reflection about the y-axis. So it would take this graph that you see right here, and it would flip it about the y-axis. So it looks like this. Now that +3, normally +3 would mean shift left 3. But, and you might have forgotten this, because this negative is right here, it reverses this sign and makes that actually go to the right 3. So you're going to take this graph right here, and you're going to shift this to the right 3, and when you do, you get this graph. One thing that you should understand is this should extend down. I'm going to erase this. This on this blue line right here, this should extend down all the way down. It shouldn't stop like it does in the picture. And that's what the graph of natural log of 3 minus x looks like. So based looking at this first one that I just put a star beside, that's the parent function of a log function. And if you know what the parent function looks like, you can do a rough sketch of the graph of any log based on what transformations are happening in here. All right, guys. There's a few practice problems for you to try. This will go along with the log rules and maybe a little bit of graphing. Feel free to use your graphing calculator when you do graph natural log. If it's a regular log, like we did in the previous practice problems, go ahead and make a table for those. But if it's a natural log, just use your graphing calculator and sketch the graph from that. So as always, if you guys need any help, feel free to email me or message me on Google Classroom. Have a great day.